Right, so we're on a little journey now through the triangles of trigonometry. And whether you realize or not, you've solved a couple different types of triangles: a right triangle, an angle-angle side, and a side-side angle. Okay, usually that stuff just kind of all blends together and kids just use good math. Like the law of sines was a key piece to, of course, the mini check. So what if I give you a side angle side? Okay, now you don't have to remember something from geometry per se, but you do have to realize that side angle side means that the angle is between the two sides. So there should be something that feels a little bit different here. And you're going to have trouble using law of sines, right? You kind of look this triangle over. It doesn't fit the law of sines. It doesn't have a match. Now, what dimension would you like to know? What dimension would allow you to use the law of sines? Okay, so that you want it, you got it. We're going to find it today. We're going to find side C. Does everybody kind of feel like, geez, if you just had side C, you'd be in business? Okay, but of course, to find side C, don't do something silly like the Pythagorean Theorem, or, you can't use any of the old ideas. We need something new. We need something new. And that something is called the Law of Cosines. Now, to find side C, we need to go on a little bit of a trip. So, you ready? We're going to go find side C. We're just actually going to find it right here. Nobody got up. You guys are still kind of trying to wake up here. We're going to do a little bit of theory. Just going to do it over here. If it was me with the notes, I would save a little bit of space because we're going to finish this problem. So if you're okay with that, kind of skip some space. It's just notes, so it's not something we're going to publish in a textbook. The more space you have, the better. But the theory that we're going to do here is to find side C, and we're going to find it for sort of just like a generic triangle. Now, the triangle I'm drawing up here kind of feels like it's laid out like the one that we started with, but we're not going to have any dimensions. Okay, we're just going to be finding, in theory, this side C. Okay, now, we can still put on A and B, and so it kind of looks like we're just drawing, as we often do, a basic triangle. To get you started here on your little tour, I'm sort of your tour guide. I need to tell you to suit up and realize that we're going to need to talk about the height. It's kind of been an interesting dimension the last few days, and so it becomes part of this triangle. So make sure you pack the height into your toolbox here before we go, or into your little bag before we go on a little journey. One more thing, X. We need to get X off the shelf, and we're going to let this be X. This is kind of one of those things where I can describe that dimension basically from the height over here to point C. I can describe it with an X because it's going to allow us to start to describe other dimensions. Now, there's a lot of letters on the board. We don't have any more room for any more letters. But I'm wondering if we could describe this side from point B to the height, if we could describe this side using letters that are on the board. Okay, so now we kind of get into our first little stop on our journey here. What do you see, Anna? A minus X is a good call. How'd you get that? Good. So A is the full distance, X, little part of it. If we subtract, we'll get that leftover part. I'm only repeating what you said because I'm recording. All right. Now, you say, so what's the point of our little journey again? I got my backpack, I got all my stuff here, but what are we trying to do? We're trying to find side C, okay? Now, what I'm going to do is I'm going to introduce you to, or I'm going to point you to something that we see out here. You kind of have to look. You see it out there? It's C squared. C squared. Now, we're going to find C, But to get there, we're going to start with c squared. And you say, what am I looking at out there? Well, you were looking at that triangle, okay? Because look, there's something that's true about that triangle, specifically in regards to c squared. And that would be that c squared equals the leg squared plus the leg squared. It's a little Pythagorean theorem that was out there in the field. It's kind of rustling in the bushes. You have to sort of be watching when it pops out. And when it pops out, it says that a minus x squared plus h squared is going to equal c squared. I can't quite tell if I'm amusing you or not. All right, good. I think I see like a smile. All right, ready for our next stop? Okay, well, this stop is just kind of the algebra stop. And the algebra stop says that we can actually do a minus x squared. We can basically, as some teachers call it, the FOIL method, or we can expand that. Now be careful, because before you expand a minus x squared, don't do that. Don't do that, because that's a math teacher's nightmare. Have you heard of a math teacher's nightmare? Well, if you've had me before, you know that I wake up at night screaming, no, no, no. And my wife calms me down and she says, how do you do a minus x squared? You kind of just think like that, right? You think a minus x, a minus x. Okay, so we have a little algebra stop. How's that algebra going? You should have an a squared, a 2ax, a minus 2ax, and a plus x squared. Now, please don't hesitate if you have a question, because I never want to imply that you should already know this. There's always good math that kids need to brush up on. I'm telling you, that's one of them. How to square a binomial. And of course, not as a math teacher's nightmare. All right, what is happening here? It's always a good time to stop and just kind of make sure that everybody's coming along. We're trying to write a formula for C, because I think a few minutes ago somebody said, I want C. So we're over here writing a formula for C, but it's looking a little bit crazy. It's got like all these letters. I want you to notice something about the letters up here. Okay, they certainly have to do with the triangle, and more specifically, we want them to have to do with the given. We want them to have to do with the side angle side dimensions. So how are we doing with that so far? Well, if you look over our formula, it's got an A in it. Okay, that's a given, but it's got the rest of this junk. Okay, so we want to kind of take this junk and we want to try to turn it into the letters that we were given so that we can find C. X squared plus h squared. What do you see? That equals b squared. Why?
Because it's like on the other side of the triangle, and then the two legs are.
There it is. Again, it's a right triangle. The two legs are x and h. Okay, it was that Pythagorean theorem again out there. Pretty cool. So that equals b squared. All of a sudden, my formula is starting to take shape. In fact, we're almost done with our little bit of our tour here, but I want to make sure you get your money's worth. So there's one more stop, but take a look at the letters that are on the board. They are letters that represent the given. The given was A, the given was B. We haven't used the angle yet. And we seem to have this X right here, which we were grateful for. We took X along, but now we're going to sort of leave it behind. We have to do something with that X. Okay, now to do that, take a look at this triangle here that Grace was pointing out. I'm talking about the triangle to the right. That triangle uses X, and it uses C, which we need to get involved. And how about B? here's kind of your question for the day. How can you relate x, c, and b? How can you relate them? When I say relate them, what you're trying to do is you're trying to write an equation that uses x, c, and b. Now this one, you might need to, what you guys don't usually have a problem with, you might have to be a little quiet because you have to listen. Do you hear it? Do you hear it? Sounds like a drum. X, C, and B. Good.
You put x over b, and then it equals cosine.
You put x over b, and it equals the cosine of c. What is that? Just in sort of your own terms. What is that? Where'd that come from? SOHCAHTOA. Adjacent is x, hypotenuse is b, and oh, look, it uses cosine. Okay, now you're a smart group. Remember, we're doing something called the Law of Cosines. We just got cosine involved. Okay, so this little guy over here, just a little sidebar, and let me help you with this piece of it. Okay, because we did this so we could solve for x, so we could find x. X equals b cosine c. X equals b cosine c. Now this x right here, remember we packed it along, but now we're going to sort of leave it behind. We're going to change it to be b cosine c. B cosine c. So, ladies and gentlemen, as we make our final turn back to our destination, we found the law of cosines. Thank you for your participation. I hope you enjoy the rest of your stay here at Math Magic Land. So I just kind of made that up as I went, but that is called the law of cosines. And look, it gives you c squared, which is only one step away from c, and it also uses all the givens. Just one more time, all the letters that are up here, A, B, and C, A, B, and C, are all the givens of our triangle. So we can come back over here and we can sort of give you what you want. That is, we can get side C. We can find side C. Come on back over to this problem. This is actually kind of your first little time to mess around with what's called the law of cosines. It's kind of fun because all you got to do is plug into it. Everybody likes plugging into formulas now and then, so you just plug in A. Okay, now, of course, that would be 8 for this problem. Notice that it gets squared. Then you plug in 2 times A, so 2 times 8, times B. For this problem, that'd be 6. Cosine of 52. So you got all that going on. And then you do B squared, which should be plus 6 squared. Yeah, play along. Check it out on a calculator. I would imagine that you're saying that you can do it, but might as well give it a shot. Just make sure that you're getting all the squares, the plus and minus signs. And don't forget to hit the cosine button. Sometimes people are so used to tapping the sine button, but make sure you push the cosine button. Okay, now of course when you get 40, that's not c, but c squared. And so please take the square root of that. Try to use the full power of your calculator. Don't do any rounding until the final step. So take the square root of your last answer, and that'll land you at about 6.39. 6.39. All right, and that is side C. It's also called the law of cosines. Now, I'm going to go back to that law of cosines in a second, but while we're working on this triangle, let's make sure we understand that you still have some work to do. Like, you still need to solve it, but it should be kind of natural now that you have these two dimensions that match. And so I don't know if you need me to give you permission, but I'll tell you that you're going to finish with the law of sines. Yes, that's fine. Finish with the law of sines and get her done. So use 6.39 with the sine of 52. As you set that up, you do have to be aware that you're putting a little bit of a rounded number into the formula, but that's all right. I have to put 639 in the formula. You could find angle B, you could find angle A. Okay, it really doesn't matter. You just have to find one of the angles. And based on the mini check that you guys turned in, it looks like that you're doing fine with the law of sines, which I would expect you to. So if you found angle B first, you would get right around 47.72, and then you can subtract from 180, and you can get right around 80.59. Now, if you found angle A first, and this is going to happen, you'll find out that your decimal differs by a couple tenths. If you found angle A first, you might feel like you're staring at more at about 80.28, but feel free to correct me. I'm kind of looking at my notes here.
Even if I did B first, but even if I subtract 180 minus 52 minus 47.72, I still get 80.28.
Okay, that's right. I said it backwards. You get 80.28. But if you found angle A first, that's where you might be looking at more like this 80.59 number, or no. Okay, sometimes the decimals can vary because of basically the use of this rounded number in the first place, this 639. Okay, it's fine. I'm going to give you credit. I look at the math that you did. I'm not trying to grade you on your rounding or maybe something with a decimal. This thing over here, this c squared equals a squared minus 2ab cosine c plus b squared. It's called the law of cosines. It actually typically gets organized just one step differently, okay, in that we will take the squares, the a squared and the b squared, and we'll put them together. Let me show you, and you might want to maybe make yourself like a little bit of a box here, okay, because the one thing about the law of cosines is that it actually works for two scenarios. It works for side, angle, side, which is what we just did. It also works for side, 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 which we will do tomorrow. But just to kind of get all the information out. So you've got side, angle, side, and side, side, side. And as I said, a little bit of a different arrangement. It just makes it easier for kids to memorize it. So the a squared and the b squared, we typically put those, and you always see it like this in a textbook, we put them together. So we call it a squared plus b squared. It's kind of interesting. If you just look at what's on the board here, you might say, hey, that's Pythagorean theorem. Well, I hope you realize from a little bit of our journey here that a lot of Pythagorean theorem came from this sketch. Okay, a lot of this theory was Pythagorean theorem. It's this minus 2ab cosine c that sort of accounts for, that sort of fixes the Pythagorean theorem. Okay, when we subtract 2ab cosine c, it now gives you the true c squared. I bet you wouldn't be surprised for me when I tell you that the law of cosines can take on two different forms. Excuse me, two more forms for a total of three. What I mean is it depends on what side. Hold on a second. A little rusty here. It depends on what side, sorry about that, whether it be c squared, b squared, or a squared that I'm trying to find. So here, I'll kind of show you the other one, and probably you'll be able to fill in the other one, because if I'm trying to find side B, that would mean that I'd have side A and side C. So a squared plus c squared. Now that would also mean that I would subtract 2ac, okay, because those would be the two sides that I have. Do you realize what angle would have to be with this setup? Remember the original one, angle C, side C. So this one would be angle B with side B. If you haven't already, just a good exercise to think about the alphabet soup for a squared. And just make sure that you have it right. I need to make sure also it's b squared plus c squared minus 2bc cosine of a. B squared plus c squared minus 2bc cosine a. Now you guys will come to realize that that formula, or those three formulas, really are all saying the same thing. They're just saying sum of the squares minus twice the sides times the cosine of that angle. But usually kids appreciate seeing all the letters, at least early on. Okay, nothing, so to speak, required tonight. Okay, just come on back for some more fun tomorrow.